Hello students, this is your chemistry lecturer. Students, in this video, I would like to talk about an important topic. And before we get into the topic, let me consider an example. Students, we are all very familiar with water. Water is an essential constituent of life. Without water, life does not exist on earth, right? Now the question is, what water is made up of? Yes, easily we can say water is made up of water molecules. Next question is, do you think water exists as one individual molecule? Yes, the answer is no. Water will not exist as one molecule. Rather, it exists as group of molecules or collection of molecules or aggregation of molecules. Here I have considered only three examples of water molecules, three molecules together. If you take a closer look at one water molecule, this water molecule is made up of one oxygen atom, two hydrogen atoms, and they are bonded by strong chemical force of attraction called bond. And we know that this water molecule will not exist alone. Instead, it is going to be existing as aggregation of molecules. Since they are existing as aggregation of molecules, definitely there must be some force of attraction present between, right? So what is that force of attraction which is holding them together, right? So the forces of attraction is shown here in dotted line, which is holding all the water molecules together, are known as intermolecular or interparticular forces of attraction, right? Now, in this video, our main focus is on intermolecular or interparticular forces of attraction. Now the question is, what are intermolecular forces of attraction? Students, these are the forces of attraction which hold the constituent particles, which can be atoms or molecules of a substance together. Now, the next question is, why should we study these interparticular forces of attraction? Right? Students, there is a necessity to learn about these intermolecular forces of attraction because the strength of these intermolecular forces of attraction have a direct influence on some of the important physical properties of substances like melting point, boiling point, vapor pressure, evaporation or volatility, viscosity, surface tension, and solubility. If there are stronger intermolecular forces of attraction present between the molecules of a substance, then molecules stick together more strongly. For example, if there are stronger intermolecular forces of attraction, then that substance is going to have higher density and molecules will stay very close to one another. Similarly, if there are stronger intermolecular forces of attraction in a substance, then the substance is going to have higher viscosity and the molecules will not slide past each other very easily. Similarly, if there are stronger intermolecular forces of attraction, then the substance is going to have higher boiling point and it is difficult to break down those stronger intermolecular forces of attraction. So this is how the intermolecular forces of attraction are going to have an impact on the physical properties of substances, right? Now let us consider one more example. Take a closer look at this. Yes, you can see water as well as acetone, and everybody is familiar with this. I mean, you students are very familiar with these two substances. Now the question is, which one of these two liquids is more volatile? Or which one of these two liquids is going to have higher boiling point or lower boiling point, right? Or which one of these two is going to evaporate faster? Now answer is, acetone is more volatile or it is going to evaporate faster than water. Now on what basis you are going to tell that answer? So to understand that, let us take a closer look at the molecules present in these liquids. We have seen this diagram already. These are the molecules of water, and we know that the water molecules are held to one another by strong forces of attraction, which are known as intermolecular forces of attraction. Similarly, in acetone also, between the molecules of acetone, we have some forces of attraction. Still, acetone is more volatile because the forces of attraction present between the molecules of acetone are weaker forces compared to the forces of attraction present between water molecules. Since the intermolecular forces of attraction are weaker in acetone, acetone is more volatile. So that means that different substances are going to have different molecules in them, and between those molecules, intermolecular forces of attraction will be present, but they will be having different strengths. For example, in acetone, the intermolecular forces of attraction are going to have lesser strength compared to the intermolecular forces of attraction present between water molecules. Now, based on how these intermolecular forces of attraction are going to be developed, we have different types of forces and different strengths for different types of forces of attraction. So let me repeat that again. Depending on how these intermolecular forces of attraction are developed, we have different types of intermolecular forces of attraction. Students, these are the major types of intermolecular forces of attraction. London forces are dispersion forces, dipole-induced dipole forces, dipole-dipole forces, and hydrogen bonds. Among these categories of intermolecular forces of attraction, these three, that is London forces, dipole-induced dipole forces, dipole-dipole forces, are together known as van der Waals forces of attraction. And moreover, these three forces of attraction are weaker forces of attraction. Among these three, if you have to have a comparison, then London forces are the weakest forces. Next stronger force is dipole-induced dipole force. Next stronger force is dipole-dipole forces. And the hydrogen bonds are going to be much more stronger forces of attraction compared to these three van der Waals forces of attraction. Apart from hydrogen bonds, there is one more type of intermolecular force of attraction, that is ion dipole forces. Hydrogen bonds and ion dipole forces are not considered as van der Waals forces, but hydrogen bonds and ion dipole forces are going to be considered as intermolecular forces of attraction. Students, in the next video, we'll talk about each of these different types of intermolecular forces of attraction, and then another video will take up some MCQs related to this particular topic and solve it. Thank you.